Right. So I just briefly go through what we just covered. We were talking about data mining applications, the data mining process, where data mining fits in, what is the relationship with other, similar terms like machine learning and other subjects. We will end with, we'll talk about techniques today. Briefly, the bulk of the presentation will be on techniques, and we will talk about issues and challenges that we have while implementing those techniques. And we will talk about some of the popular data mining tools in operations today. Um, and and we will end there. So we just spoke about, for people, this is for people who are not present there. So data mining is defined as something that is not trivial, implicit, which is previously unknown, and potentially useful. That is the criteria to define a data mining. And of course, as you can see, we often listen to a lot of terms: data mining, data analytics, methods and algorithms, machine learning, and so on. This is where we put things in perspective. So data mining is a combination of machine learning, computer science theory, as well as database. I will just rush through what we have already covered. We spoke about why data mining is important, the growing importance of data mining because of explosion of data, and why we are starving for knowledge, irrespective of the fact that we are actually drowning in data. And we spoke why data mining is important instead of traditional data analysis, and how important it is become everywhere. We spoke about levels of intelligence. Most companies are in the bottom quadrant. The degree of intelligence is low, as well as the business value is also low. So as you progress, as companies mature, you get into statistical analysis, forecasting, and beyond forecasting is predictive modeling. And beyond predictive modeling, is given your constraints, what is the best way to optimize your, your profitability or any output. We spoke about data mining applications is almost everywhere. We have it in marketing, banking, manufacturing, healthcare, and there is no single area which has been not touched. Some of the popular areas, the search engines, the spam filtering that we have is all based on data mining applications. Advertising, when you go to your emails, even now, Gmail, based on what you have communicated, you get advertising based on your communication. These are purely based on data mining applications. The Netflix recommender systems is purely a data mining, a good application of data mining tool. And of course, the Facebook news feed is based on your interests, hobbies, is also a data mining tool. Just to put in perspective where data mining stands, as I mentioned last time, the bulk of your work, maybe 70 to 80% of your work, will be based on getting the target data, preprocessing the data, and transforming the data. And the data mining is a very small portion of your task. And by virtue of having a lot of new tools and techniques, you are able to concise that. But most of your time, even now, is onto pre-processing the data, transforming the data, and getting the data right in order to do in order to implement the data mining algorithm. Because data, in fact, is noisy. Yes, you may have to transform it, you may have to normalize it, you may have to do a lot of things with it. So as I mentioned, data cleaning is required, data integration, production. And today we will spend most of your time on talking about the specific techniques. One way to look at the data mining is looking at the data mining issues, techniques as predictive as well as descriptive. When we talk about predictive, we are predicting unknown values. So there is an outcome of interest. Sometimes it is called, in machine learning terms, it is called supervised machine learning. While in descriptive, it is a purely exploratory thing. You are trying to find patterns within the data, trying to understand how the data is structured. So within descriptive, you have clusters. So you have clustering means you don't have the outcome of interest, but you have a set of customers whom you would like to segment into. These customers are high value, low value, medium value, or these customers are high spenders, low spenders, medium spenders, and it can so we can do several kind of clusterings different based on our basic objective. On predictive, we have classification, so we know the outcome of interest here. So we know a customer, for example, may belong to, someone who is likely to churn, who is likely to leave leave your company. So that is a kind of classification. So churn versus non-churn is a kind of classification. Or somebody you can dissect your your patient base in healthcare as vulnerable, medium vulnerable, very vulnerable, medium, and not at all vulnerable. So these are classifications. So we know where to place people, and we take the data set and decide, okay, these people are, based on the data, these people are highly vulnerable, these people are less, and these people are not at all vulnerable. Regression is another technique we use. Regression, when we spoke about regression, there is a inherent linear or non-linear dependency that the variables have with the outcome of interest. We will talk about a little bit more when we get into the specifics. And of course, prediction, we are trying to predict outcome of interest. So we are trying to find out, given a new case, so we have a set of data and we know how people are behaved in a specific manner. And then the now new case comes based on their attributes. How can we place them, and where do we place them? Where do we place them in terms of is the person going to be a good loan applicant, for example? So there have been X loan applicants and the default rate has been X. We want to find out, we want to ensure that to minimize our risk, that this applicant's default rate should be good, right? So based on your previous data, the data will tell you how to place this customer in high risk area or the low risk area. Association rules are correlations between items. So the good example is a market basket analysis. You go to a grocery store and you buy a lot of things. A lot of people buy a lot of things. So can we find patterns from there? If people buy milk, are they also buying bread? If people buy bread, are they also buying eggs? 10 days after buying eggs, are they buying X item or not? So those are association rules. So you tend to find patterns of how people shop. So based on how people shop, you are going to advertise or make promotions, or you can orient your marketing strategies towards, taking advantage of how they shop. Sequence discovery is a sequence of events that happens one after another, and understanding what sequence precede and what sequence succeed. So it can be a medical situation, first X happens, then it's followed by other events. So one way to look at, there are different ways to look at data mining techniques. This is very small. Sorry for the fonts there. But one way to look at is basically exploratory or descriptive. What I mentioned is you are trying to explain the past, something that has already happened. And one way to look at is, it can be univariate, or which is one variable, and it can be a bivariate. Within bivariate, there are different ways and techniques to depict your data. So these are some basic techniques that you have already used in your Excel or PowerPoint. Whenever you do, you make your presentations, you provide averages, mode, median, and provide, okay, this X% of your people are doing X. 70% of your people have a satisfaction rating of 8 or above, and so on. And when we are talking of bivariate, so we are talking of two different structures. So for example, the amount of spend and the satisfaction. So I'm more satisfied with your company, I spend more. So is there a correlation between? So those are bivariate things. But we will not get into these details, but this is again predictive, one way to looking at it. I just spoke about the different techniques here. These are small fonts, so I won't go deeper into that. But I will just get into the supervised, the two kind of machine learning we have. We know the machine learning is two types. One is supervised, where we know the outcome of interest is known. Outcome of interest is known means, for example, will this customer churn or not churn? Will this customer be categorized as A class customer, B class customer, or the C class customer? The outcome of interest is no. In unsupervised machine learning, we do not have an outcome of interest. We do not know how to place that customer. We do not have a good understanding of, but still it is important. Why it is important? Because we would like to segment these people in different segments and understand what these segments are. So, for example, there will be people who just, in a marketing situation, there are people who like lower price more than anything else. There will be a segment who prefer high quality as a different segment. And there will be yet another segment who require a faster delivery process as a segment. So even though you don't have an outcome of interest, the data is still very important to understand. Based on your understanding of the segments, you are going to orientation as a company, as a marketer, to, okay, these people need, price, so you cannot offer them high prices, sell a item that is high price, or you can't offer promotions for, say, luxury items, for example. And these customers who look for faster delivery process, you need to advertise them or provide promotions that are really addressing their requirements. So that is about unsupervised learning. We will go into details of those techniques a little later. But just so you know, and briefly, labeled supervised learning is labeled outcome of interest. And we need to, for a new case, for a new record, new customer that is coming in, based on his behavior or demographic attributes, we need to find out how can we place this customer. Okay. So what is the outcome of this customer likely to be? Is this customer likely to buy my product? So X customer is age 35, income of $80,000, and comes from this city and has this kind of behavior pattern, and actually bought this product. And we have a list of all those customers. And we have a new customer who is age 28 and has so on variables. How can we place them? Is he likely to buy or not likely to buy? So supervised learning is something that will address that fact. So supervised learning it can predict a category. It can also predict a numeric variable. It is not just A, B, or C. It can give you a probability of how likely this customer is going to buy your product. And the use of supervised learning is in many. We use it in even text mining, image recognition, and so on. I will come to those when I speak about details. So as I mentioned, classification is a popular supervised learning. So yes, please. Okay, each record has an output class, which is predefined. Okay. And we create a model based on the data that we have. So we have demographic variables, we have buyer behavior, and we have a series of data. Demographic variables could be age, income, gender, and so on. Yes, please.
If I had some demographic variables but not others,
yes, you can. You can. In the absence of most of our marketers who have no idea of buyer behavior, do that. So they have no other options than to just do it based on and you will still get some learning. You might get some learning like females prefer your product more than males. People who are 18 to 34 will prefer your product more than 50 to 64, for example. Those kind of insights you are going to have. Demographic is still very important. Even now, most companies do not have proper information about the customers, except what they fill in, right? For example, you go to a retail, that is why most companies are now getting into loyalty marketing, so that they can get more information about you. Otherwise, basic information is, they will just, when you go to a store, what information do they have? They just have how frequently you shop, maybe, based on your card or whatever you shop on. They don't have anything else. In some cases, when you look for a coupon or anything, they will get your age, income, and gender. That is all they have. Correct, correct. So most companies even now are still using those demographic variables to generate, to predict income or predict your outcome. Whatever you get is based on what you have provided. They have no way of understanding what you have not provided. So there's still useful information. So basically what we are doing, yes please. Yes, there are tools that define it. That is what I'm talking about right now. So classification is one such tool. And there are within tools, there are algorithms. So we will talk about, I will just mention a few algorithms that we use. And algorithm is not my domain, but it is a statistical way of looking at things. And you can have the same purpose, but different algorithms are made by different professionals, and you can have different results based on what they have inputted into your. And most of the algorithm is a black box, but we'll try to attempt to tell you what exactly happens in a brief overview. So what we do is we create a model. So we have the data of their buyer behavior and the demographics, and we create a model. And we create the model and train we do a training set. So what we do is, as you can see, there is a training set, there's a validation test, and a test set. So what we have done is you have a database, right? You have say 1,000 records. So you usually 60% of your record go into your training set, 20% go into your validation set, and other 20% go to your test set. So what you do with the 60% is you are training the data to find out the pattern. So you may have a pattern which says, okay, females and 18 to 34 and income over 80,000 are your, this may be a business rule that comes from your training set. Okay, and in the validation set, you use several algorithms. So your algorithm may be 3 or 4 or 5, whatever you use. So basically in validation set, you are tweaking your best model. You are trying to select the best model. So in training set, you are using all the models and getting different results. In the validation set, you are tweaking to get the best model. And the test set is your test, is your final, you are using it to really do the test. So in your validation test will tell you which models are working and which models are not working. You will get a sense of your accuracy of all your models. So you may have different algorithms that you have used to generate. For example, in this particular example, you have age, salary, profession, location, and you have the customer type, and you have the classifier, which is the algorithm that you use. And the decision rule is, it will have all those salary and other information, and will give you a rule: is he a good customer or a bad customer? Okay. So basically, all these three sets that we spoke about are mutually exclusive. So there is no overlap between one another. So one you use to learn, the other you use to test, to get the fine-tune the model, and the third one you use to deploy the model. So finally you deploy the model and they get you prediction. So given the old data about customers and payments, you predict the new applicant's loan eligibility. So where are they used? These are used in direct marketing. So for example, today I don't want to send all my, when we send statement inserts, it costs a lot of money. You spend the money on printing and postage and so on. I want to send it to my best customers. So I want to rank my customers based on best to worst, and I want to send maybe 30% of the customers. So I will save a lot of money, right? Because all this cost money. A lot of people nowadays just take the flyers and throw it. So who are the customers who are more likely to buy? It is based on their past behavior. So we have the past behavior here, and we are trying to predict the outcome, what will happen. So what I'm doing is instead of getting, instead of emailing or sending statement inserts to all the people, I'm just getting a sample of my top 25 or top 50 or whatever will be the case. Depends on how much I'm willing to spend. Who have the highest probability of taking action. That is what we do. So direct marketing is one area. Another area is to, if you are going to detect fraud, for example, uh, that is this fraud. This is very increasingly being used in fraud detection. So you know what are the attributes that have created fraud, and there is a new record. You can predict whether the new customer is going to be a fraud customer. And predicting churn, for example, you know what are the different attributes. For example, in a telecom company, people may have X amount of billing, and they must have had this kind of issues, and then it led to the churn. So if you can map all this data, and you have a new customers, or you have an X customer, you can find out, okay, these customers are behaving similarly, and I can predict that these customers are very similar to are likely to change or not change. And of course, spam. The spam that goes into our email box are purely based on classification, technique. So what they do is the features that is used to classify an email as a spam or not spam is based on who is sending it, the title. The title, sometimes it's based on what some of the keywords if you use. Even now, if you send a mass email with some certain keywords such as buy or something, hurry up, something like that, it will go into spam, because the spam filtering works on the basis of specific keywords that are people spam, and based on the text length, based on specific words within the text. So spam filtering is a big way how classification is used. Some of the classification methods are nearest neighbor, regression. So we can use regression to classify people. So it can be linear as well as non-linear. And there is a decision tree, which is called, classification or regression trees, in other words, which also divides, people into different classes. And of course, neural networks. Neural networks takes after our function of the brain, where one neuron communicates with another, and then it goes to another, and finally the output is what you do. So, for example, your thought and your action is all based on transmission of your information from one neuron to another. It's a very black box, but this neural networks is something that has been taken from this model to try to replicate the working of the brain. We will talk about one algorithm called K nearest neighbor, and so we use K nearest neighbor for classification as well as prediction. For example, real estate pricing. So we know Mississauga X postal code. We have several houses with, this is the size of the house, 3,500 square feet, 4 bedrooms, 5 bathrooms, and at this street, and we know what is the price, and we can, based on real estate realtors, actually they predict the price of similar houses based on where they are located. So it's a very basic example of how classification is used on the K nearest neighbor method. So it means that if an object is closer to similar nearest object, whatever it is closest to. For example, how it works is, so there is an object and there are 5 other items near it, right? Out of those 5 other items, 3 are good and 2 are bad. So what it does is, this object, if it is similar to those 5 items, then there will be voting. So this object is likely to be 3 by 5. So if you talk in terms of probability, this will be 60% good. So 3 are good and 2 are bad. So this will have a probability of 60% good. Or if there is a voting, the majority is good, so this item can be good. So this is the concept of K nearest neighbor. So it will look at the nearest neighbor, and the nearest neighbor could be in terms of your different attributes. It is very easy to visualize real estate pricing, but in terms of a customer, it may be my nearest neighbor, may be someone who is behaving like me, has the same attributes as me. So similar kind of age profile, similar kind of income profile, similar kind of buying behavior. So I will look at those people and try to predict what will happen to me. So am I likely to buy or am I not likely to buy? Yes, please.
So, for example, in this case, like we would have a sample model.
Yes.
So, which has, for example, we take up 5 cases. So, there's a 5 case that I give a sample example, and
Yes.
then I'm finding a correlation or like comparing it with the other model.
Yes.
To predict that. So, like your correlation you're finding.
No, there is no correlation here. So first, yes, there is something called Euclidean distance. So based on different variables, for example, your income is 80K, my income is 80K, your age is X, my age is X, and you have several different factors. First of all, decide who are your nearest neighbor. Right? Of all the cases that I have, my nearest neighbor may be 10. Okay, people who come into my profile, my buying behavior, my profile. So I first of all identify those 10 people. Then look at those 10 people and find out what classes are they in. Okay, just suppose 7 people belong to my class, 7 people are A class, 3 people are B class. So I'm more likely to be in the A class. That is how it looks, what the algorithm does. Or, in the other words, you can say there is a 70% chance that you will be in the A class. So there are 2 ways of looking. So it can be a probability or it can be a deterministic. So we use something called Euclidean distance. So it is nothing but you based on different attributes, you normalize all the numbers, because age, income, they are not comparable, right? So you basically what you do is normalize them. Everything is from 0 to 1. So all you are seeing is values between 0 and 1. One is 0.05, another is 0.10. Everything is between 0 and 1. Yes, please.
If you wanted a particular one where they could like give it more weight,
well, the model will ascertain it. If a particular feature is really important, when you run the data, it will automatically come into. You don't have to do anything. To ascertain weights when you get into algorithms such as neural networks. Neural networks algorithms are based on weights. They do not have the single weight. So the input variables are there. You ascertain different weights to different input variables, and you have an output variable. What happens inside are all non-linear regression. It's a very black box. Okay. All you know is you have ascertained weights to different attributes, and you are getting an outcome. So that is all in neural networks. But in a classification, you are not giving weights. It will be the algorithm itself will tell you what it is. In regression, it will tell you exactly what weights are important. For example, if of all your attributes, which attributes are important, which attributes are not. So you may give 150 attributes, and you will see 5 or 6 attributes that are explaining a model, and rest 144 are really they will contribute in some way or the other, but they will contribute 0.9% or maybe 10% or maybe 8%, 20%. But if you are able to explain the entire process, 80% of your customer behavior is explained, then your job is done. It's a huge job. In the age of uncertainty and a lot of things happening, anything that is more than 60% is considered quite good in terms of predictive behavior.
So, and I have just see, if you have multiple variables, like you can pick a group of those and take them as a single, and then from the probability of running those through the algorithm, you decide which one is the most important to deal with it as a model.
And then you would eliminate the other variables.
It's not eliminate, so you can take the age, see the locations together, genders, and run them. And maybe you eliminate another one and pick another variables and see how it can affect the model. If it is drop, the percentage.
Yeah, run it with or without.
It's not like, okay, you have the magic, okay, the age is going to decide which one. You have to run multiple variables to see which ones can affect the most important.
Right, and remember, the computer doesn't understand age or income or anything, right? all it understands is a series of values, which is why you need normalization. So age, people having age from, yes please, people having age between say 20 to 100, they are all normalized. So the computer will see is our values between 0 and 1. So it may see 0.2 to, instead of 20 years to 100 years, it may see 0.2 to 1. Okay? And your income will similarly, because otherwise you are not going to compare income and age, right? So all your attributes need to be normalized. And then it is going to, the algorithm is to combine all these different attributes and tell you what is more important and what is not important. So first, normalizing is very important in clusters. So what are the benefits of k nearest neighbors? The benefits of k nearest neighbor is training is extremely fast. It's very robust to noisy data. It's simple and easy, and you can see it. But it's a very computationally intensive because you have to do the k is very iterative process, right? You can start with 2, then you have to do with 5 or 10 or whatever, and every time you have to go through different combinations of attributes. So it requires a lot of computational efforts, and therefore it also needs sufficient training data. And as I mentioned, curse of dimensionality, you need a lot of information to literally learn the model. And notion of proximity is vague, means, how do you define proximity? For example, for age, somebody who is A class and B class, how do you define the proximity? Age is easy to define because it's a number. But somebody who is in a class, is in a category, for example, somebody is in an A class category or B class categories, how do you define the distance? Those are the challenges with the nearest neighbor. Yes. Yes.
Put a metric on it and say.
Yes. So it is. The other way of categorizing is supervised learning as classification and regression trees, which is also called decision trees. So what you do is, this is a very simple example. If you look there, you'll see yes and no is whether people are buying or not buying. So if their age is less than equal to 30 and is a student, then he is likely to buy. And no, yes is, and is a student is likely to buy. If he is between 31 to 40, he is definitely likely to buy. And if he is over 40 and credit rating is more than fair, then he is likely to buy. This is a hypothetical situation. So in decision trees, what you do is find different rules. So you start based on your different combinations of your data, it gives you rules of different scenarios which are valid. And all these rules are mutually exclusive and exhaustive. So you may end up with, actually every case is a rule, right? But you can't have, if there are a million cases, you can't have a million rules. So you have to generalize this. You have to cut them off and find out which are the most important rules. So what you do is there is a kind of splitting. So it will say the rules come is if this happens, then this, else this. So this is the algorithm here. So there can be many rules. There can be conflicting rules, and in which case the most important attribute determines how to resolve conflicts. So we start with the most basic rules first, and then the most important rule, then we go into next set of rules. So basically pruning is very important. It's like a tree. Pruning is very important. Otherwise you are going to end up with, so you have to understand what are the basic rules of how people behave in terms of how people are going to buy or whatever. So this algorithm will favor the rule that has the most accuracy. And as I mentioned, all these, when they create these rules, all these trees are mutually exclusive and they are exhaustive. Exhaustive and homogeneous means they are very similar within themselves and very different from other trees. Where are we using this? We are again using this in churn analysis. And of course, the size of split are again a statistical algorithm measure. There are something called Gini index, standard deviation, that determines where the split will stop.
Is it always a binary split or?
It is not necessarily a binary split. It can be a three-way split. I am provided a binary split for simplification purposes, but it can be multiple, it can be 10 splits also. So what are the pros of these? The advantages are, these are very easy to interpret. You can see them basically. You can look and see, okay, this is what has happened. Okay, anybody who is 31 to 40 is definitely likely to buy. So it is very easy to interpret, easy to easy to generalize, and this training is less. Less training cost, and it's very fast. That is why because the training time is less, it takes faster. And it is widely used, very widely used. The algorithm is very popular, and it can also work with some missing values. If there are values are missing, it can still, because you will not have exhaustive values of all different situations, right? So it still can work there. And it is very robust. Even if there is some noisy data there, it will still can generate those rules. And it can take care of large number of features. So you can put 155 features, and it can tell you the 5 features that are important, the rules that determines how people behave, or how people purchase, or how people have this kind of disease, for example, and very automated process. The cons are, depending on where your split is, you can overfit. Overfitting is a situation where your model has completely learned. In the training set, it has completely learned, and it has totally replicated the rule. But the disadvantage is when it works on the test data, it throws away error. When you check how many it got right in terms of accuracy and inaccuracy, you will see there's the level of accuracy is much higher than what you expected. So that is overfitting. So you have to be very careful. Overfitting is a big issue, big challenges. I will come to that as one of the big challenges with the data mining. So we have to be very careful.
To run this algorithm, like you start with the
Yes.
across a variable, does the algorithm itself, the splits, or does one have a unique?
Right now, we have several situations where very little input is required from your side. The algorithm itself can give you the splits right now. And within decision tree, there are several different kind of algorithms that you can use. You are going to get different results with it. And one of the big disadvantages of algorithm is if you change any data, and the decision tree itself will change. So the rules will change. So it is very sensitive to minor changes. And that is one big disadvantage with you may have heard of random forest. Random forest is nothing but a series of decision trees. What you do is, instead of having one decision tree, you have a sample of decision trees. And so there are different kind of trees. So you look at it as a different tree. And when you have to decide, and different trees have different rules, right? And when you have a new record, you are going to test this record with all those trees. So instead of one decision tree telling you what the rule is, it will have maybe 1,000 decision trees telling you where this person is. So you are going to have a more stronger, random forest is one of the most stronger, has more stronger applications because it's much more accurate than usual decision tree. It is very accurate. You can see that people who are participating in Kaggle competitions and even people who have won in Netflix recommendations, the 1 million contest, we're using random forest as one of the algorithms. So a random forest is very critical. It uses decision tree as the basic structure of how to process records. Where do we use this? We use this to classify medical patients in terms of whether they have a disease or not disease. So you have a different situation, right? Whether this person has this age, whether their X blood profile is this, and if so, then we split. People with blood profile can have or may not have. Then you are going to look at their maybe their ultrasound characteristics. Then you will get into further within ultrasound. There may be further splits. So basically, medical classifications, understanding whether a patient is vulnerable or not vulnerable, having this disease or not disease, not having is a major application. The other application is your insurability. So when people underwrite your application and put you in categories of risk, they decide based on different kind of factors using decision trees. Neural network is, as I mentioned, is a very popular, but it's definitely a black box to many. What happens is inside is linear and non-linear regression. So what we do is you have a set of inputs and you give weights to all those inputs. And there is like neurons, there are transmission of information from different nodes. Around the circles that you see are different nodes. And there are a series of nodes that interplay with each other, and you finally get an output, which is a weighted sum. So, and neural networks is very, very critical. It has been used in image recognition, your handwriting recognition. It has very prevalent use in recognition of handwritings. And one advantage of neural networks is it has very high tolerance to noisy data. So even if your data is noisy, it will still find ways to deliver the classification. And it can handle large number of data. And as I mentioned, speech recognition. I believe Siri on iPhone is based on neural networks. When you speak to your phone, all this.
Google is spending a lot of
Yes. So if you are really wanting to further your career, this is one area to look, and which has very significant applications and is quite appealing. You'll see a lot of professors nowadays who are teaching data science very interested in doing research on this. For us, the middle portion is a black box. You have a weighted sum. Your output is a weighted sum. Is all you need to know. It is very difficult to understand is the data disadvantage, and it also can suffer from overfitting, and its training time is quite long because there are so much. You put a weighted sum there, and that weighted sum goes to another output, so it's a longer time. And the verification is very difficult. Unlike a decision tree where everything is transparent, you can see, okay, this is linked to this. Here it's a black box. So interpretation is not all that simple. The other supervised learning are support vector machines, very similar to neural networks, except difference is everything happens on a n-dimensional space. So it creates a hyperplane and that classifies, there are different attributes and it does classifications on a hyperplane. But otherwise, the algorithm there is very similar to the neural networks. Bayesian classification is again a statistical classifier. It is based on posterior probability, which means given this probability, what is the likelihood that this could happen? So basically, given the probability that X will buy, X is 31 to 40, and with this kind of income, what is the likelihood that And what you do is every case that you have adds to that probability, subtracts to that probability. So a series of sets actually helps you to model the entire series of data sets help you to understand the model. Ensemble methods is a combination method. As I mentioned, instead of using one method, you use series of methods to test your model so that it increases accuracy. When you have 10 different methods or 5 different algorithms that you're using, what you do is, and you use four or five of them, and you get the same kind of results, your confidence in your prediction is improved. And in all these Kaggle competitions, they use all these ensemble methods. They use bagging, boosting. Bagging is nothing but they use different predictions and they will average it out. In boosting, they will give a weighted vote. So they will get more votes to random forest, less votes to say trees and so on. And let's see if I can mute everyone. How do we evaluate different models? So basically we have, this is called a confusion method. So you have a matrix where you have the predicted class on the columns and actual class on the rows or whatever it is. And you have true positives, which means you predicted them as positive and they came as positive. Means you predicted this person will be A class and they came as A class. True negatives is you predicted them as A class and they came as B class. False positives is also similarly, it's all depends on what you have predicted and what you actually arrived at. So it may be a number of people, right? So 30, 40, 30, 20, whatever, it may adds up to your total 100%. And your accuracy is going to be how much whom you predicted as will be good turned out to be good, plus whom you predicted will be bad turned out to be bad, divided by the all total number of cases. That is your accuracy. And
it's the validation
sector. Correct. So you use, when you use your model to evaluate which of your model is doing better than the other, this is one way to look at it. And you use a series of those metrics. You have accuracy, you have error rate, which is derived from accuracy. You have precision, you have recall, and you have the receiver operating characteristics curve, which has a graph between. Yes, please.
How do these equations apply to more classes?
When you have more classes?
Like say you're deciding between 4 different classes.
It will be not it's 4 by 4.
Yeah, it will be 4. This is a very simplistic way of looking at it.
So, but here you compare each one by one.
One is expected and one actually.
Correct.
Yeah.
But you still will have true positives, right?
Yeah.
So you will still have people who are predicted A, B, C, D and turned out to be A, B, C, D. Those are your true positives. Correct. Yeah, we are talking about positive and negatives in terms of how well you predicted. It could be 7 classes or 8 classes, based on whether you are accurate or inaccurate. So prediction and actual is you accurately predicted or did not actually predict.
Whether yes or no.
Correct.
It's not for each class.
Yeah, you will initially start with your 4 by 4 or 7 by 7 or whatever it is the case. But ultimately, you will end up with how many you have correctly predicted and how many you have not correctly predicted, or how many you have correctly predicted as incorrect and how many you have incorrectly predicted as correct. Yeah, ultimately, you will end up with this method. Why is it? Okay, let's get into supervised learning. In supervised learning, we know there is no predefined class. So there is no outcome of interest. So we do not know whether we are putting them into A class or B class or C class. So by nature, it's a very exploratory process. We are trying to find out where customers, trying to segment customers, for example. And we are trying to find out what are the different traits of the customers. So we are trying to learn by examples, unlike supervised. And there is no preconceived idea of outcome. So we are trying to, all these segments that we have are very homogeneous among themselves and very heterogeneous with as compared to other segments. So less difference among themselves, high difference when compared to other cases outside the segments. So that is the criterion. And the distance is based on the partition criteria. Where are we using this? We are using it almost everywhere. So the recommendation engine that you see from Netflix, that you are likely to love these movies, is purely based on, it's called collaborative filtering. It's based on clustering. It is an unsupervised approach. We are using it for city planning, for example, identifying similar kind of houses, for example, property taxes ascertainment. Okay, this is the kind of house, this is the area, and this is how much we should charge for property taxes. Urban planning is one area. Even understanding patterns of atmospheric, climate changes, and these are a lot of applications. Marketing, of course, marketing segmentation is the most popular use. So we do not know where our customers are, what are different. We do not know how customers behave. So we just go ahead and segment our customers and try to find out the different attributes, the key attributes that customers have. So basically, you're trying to find out different, okay, this 10% of customers are your ex-customers, high spenders, spend a lot of money, spend very frequently. They are your best customers. It may be your best customers when you profile them, okay, but you do not know them when you do it. And these customers, as I mentioned, are customers who prefer faster delivery, or the customers prefer high price, lower prices, and so on. So, and of course, what are the steps? First, we find out. We actually extract the features that are important. For example, one area could be we extract the main features that determine a particular segment. Okay, then based on that, we decide a proximity, a measure of proximity, and then we have a clustering algorithm, and we find similar kind of cases and segregate them into. Correct. I mean, it can be used anywhere. Wherever you do not have an outcome of interest, it can be used anywhere. Yes. Yes. I mean, medical, of course, medical uses is definitely there. So you're trying to find out whether any similar kind of cases. So X person has this kind of symptoms and had this kind of disease. So Y person has similar kind of symptoms and therefore will have the same kind of disease. Correct. Yeah, absolutely. Yes. Yes. Right. What are the challenges with the interpretability and usability is very important cluster. So you can come up with different clusters, but ultimately, whenever we do market segmentation, you need to ensure that first of all, there are a few things that are very important. First of all, the cases that you have in each of these clusters need to be good enough. Good enough in the sense you can action them. Just suppose a case has 10 people in it. It may be a cluster on its own, but you are not going to use it. So something that you can use it as a marketer or as a healthcare professional. First of all, the segment size should be good. So you cannot have very small size segments, or you cannot have very high size segments. The other thing is the segment should make sense. So it will make sense only when you profile them. Once you segment them, segmentation is very easy. You do algorithm, it will segment in people. But then you have to find out whether it makes human sense to you. And human sense is from the business perspective, whether you can, if you're a marketer, whether segmenting in this manner really makes sense. So you can have n number of combinations, right? So it's a very iterative exercise when you try to interpret it. So that is a very key step in segmentation. So having done the segmentation, profile them. Profile them means understand their behavior, their demographic profile, and try to find out whether it makes sense or not. If it doesn't make sense, maybe you have to abandon it. It's maybe just a academic exercise, so you may have to abandon. You might have to find other ways of segmentation. There are many combinations. There is no right or wrong answers, which makes the process very difficult. So you can't say, okay, you segment my customers and I will get the same result as you. Cannot. It is all depends on how you, what attributes you have been taken. And also depends on what features you're taking. So if you have extracted the right features, and maybe you may have to do something with the features, you might have to combine features. And generally,